Hey folks, I thought I would make a quick little tutorial here to show you how we can do a sample size calculation for repeated measures in ANOVA. Now, this is actually quite simple if you just think about, it's just an extension of a simple ANOVA, except we're going to do a repeated measures. Now in this case, it's going to be a diet trial where we're going to compare two groups. And that's our control group that nothing happens to them, and our test group. Okay, so what we're doing here is we're just plotting, and part of why we need to do this is because we're actually going to kind of simulate what our expectation would be if our study worked out. So we have our black bar, which is our control group. No real change. I just changed it to 3 just in case, sometimes it happens. And my red group gets a little bit of weight change, and then it reverts back. If you notice, many diet studies do this, where they go down for a little bit and then they come back up. They come close. Okay, so this is roughly what we're looking at. And what I drew also is our minimum for change. So if our graph looks like this, we just barely achieved significance. We're hoping for more, but this is the least we will accept. Okay, so now our sample size for each of these, we're going to assume is going to be about 50. And if we measure our average for these guys, now for our red group, our treatment group, is going to be sample size of 50 again. And 145, 150, 140, okay. And this is what we're going to call this is what's going to help us define our effect size. That's why we did this. Okay, so now let's go ahead and just remember our variables. Our alpha is usually 0.5, and our power is usually 0.8. Now you remember, we can change these variables if we need to, so there is none of these are cast in stone. Most of us who are beginners, we're just going to stick with these until we know better. And we of course have our 4 measures. Now rho is kind of a sad story here because GPower doesn't really have much that it can help us with. There are ways that we can kind of get by, and we'll just work with the defaults. Okay. Now, our standard deviation. Now that one, we really have to get an idea. And so what I did was I looked at some of the past studies, and of course you know that your standard deviation is the number, the root of the number, the confidence intervals, and 2 times the z statistic, or the t statistic, really. For this study that I was looking at, it was 56, and the difference between the two groups was from negative 2.3 all the way up to 1.2. And then we have 2 times, and again I said the t statistic. And 56 minus 1 is 55, and the t for that is just a little over 2. And that gives us about 6.5. So let's just round it off to 6.55. We're going to use all these variables, okay? So these are all estimates, remember. So here we go to our f-tests, and we look for the ANOVA, repeated measures between factors. And of course, we're going to do a test beforehand. And the effect size. This is where we're going to use these numbers. So let's go determine this. So we want our effect size for means. And our standard deviation is, of course, there we go, 0.555. Okay. And then we, of course, our group 1 and our group 2 means and their sizes. 148.5, size of 50. Size doesn't matter too much yet, but it will later. Okay, 144, 50. We can also do unequal sizes, but let's not overcomplicate our lives. So there's our effect size. We go send it over, close our drawer. Now, let's just make sure that everything else checks. another 0.8. 2 groups, 4 measurements. This, we're just going to leave it at the default of 0.5. We can later play along, we can play and see what it'll give us. But for the meantime, we'll leave it as that. So let's calculate. Okay, we've got a critical of 407, and our sample size is 44 with the parameters we requested. Now, we don't usually just want to look at a single number, so what we're going to do is we're going to plot these values. We're going to plot them as a function of a function of effect size that will give us sample size. And we're going to give small measurements so that it will give us small increments. So on our y, it's going to tell us how many we need for a certain effect. Voila. Now check this out. So now look at this. We have an effect size that as it shrinks, our sample size grows. And as the effect size grows, the sample size shrinks. As a matter of fact, let's get some perspective here and start from our default position of about 0.34. And notice we go to the left and our sample grows dramatically. And we go to the right and our sample shrinks, which should make perfect sense. But moving right along, this you can export it to an Excel sheet and send it to somebody. But, well, I think you get the gist. So that gives you an idea. We can also plot additional powers, and we have other parameters we can test. So I hope this helped you out. If you got any questions, let me know. Bye-bye.